Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve probability and statistics paper 9709/53 for the session May June 25. Let's start with the session with the solution to question number 1. The first question say for a set of 40 values of x, it is found that sum of x minus k is equal to 836.0. Sum of x minus k whole squared is equal to 25,000 2,54,000, sorry, 25,410.8, where k is a constant. Given that mean of these 40 values is 124, find the value of k. So it is a coding data. So for coding data we will have to first split this, I mean simplify this. Sum of x minus k is equal to 836. Then if we simplify this, it is going to be sum of x minus k into how much is the mean? Mean is 40, so 40k is equal to 836. Well, now our mean is, look at this, mean is 40 and total, sorry, mean is not 40, number of total values is 40 and mean is 124. So sum of x is 40 into mean, 40 into 124 minus 40k is equal to 836. Now our 40k is going to be, 40k is equal to 836 minus 49. No, it should be negative symbol in front of 40k. So minus 4960. Hence our k is, if we divide this by 40, it is going to be 103.1 is the answer. Okay, then the next one says find the standard deviation of these 40 values of x. Remember, coding data is not applicable for standard deviation or variance, so simply we will apply our concept. So standard deviation is equal to square root over the sum of x minus k whole squared over total number of data is 40 minus x sum of x minus k over 40, then whole square. Okay, let's substitute the values. The value of sum of x minus k whole square is 25410 over 40 minus sum of x minus k is 836 over 40, then whole square. So finally our standard deviation is going to be, if we use our calculator, it is going to be 14.1 as the final answer. Let's see the next question. Question number 2 says at a large college, all students who study science also study exactly one of art or drama or music. 20% of these students study art, 45% students study drama, and 35% study music. 3 students are selected at random from the students who study science. Find the probability that at least one of these students studies drama. So it's all about drama. Let us see what is the P for drama. P is For drama, P is 35%. Okay, sorry, drama is 45%. 45%, so it's 0.45. That means those who study drama, probability of them is 0.45. So those who don't study drama, their probability is 0.55. And as it is given in the question, total number of student is given, that's why it belongs to binomial distribution. And for binomial distribution, the parameters are n and p. Total number is 3 and p is 0.45. Now they have told that 3 students are selected. Find the probability that at least one of these. So at least one of this means it may be more or equal to one student. So that, what does that mean? Out of 3, there may be one student who took drama, there may be 2 students who took drama, or there may be all 3 students who took drama, equal to 3. So when our there is only one student out of 3 who took drama, is out of 3, one has been chosen who took drama for 0.45, and rest 2 didn't take drama. So for them it is 0.55. How many? 2 students. First case. And if there are 2 students who took drama, so out of 3, 2 has been chosen, and these 2 have taken drama, for which their probability is 0.45 square. The other one didn't take drama, so his probability will be 0.55 once. Then the third case is plus, out of 3, all 3 have taken drama, so it is 0.45. All 3 have taken drama, so there is no student who didn't take drama. There is no one, so their degree is 0. Now if we simplify this, 3 choose 1. 3 choose 1 is actually 3. So 3 into 0.45, 0.45 into 0.55 square, plus 3 choose 2 is also 3. You can use your calculator for getting the result, into 0.45 square, 0.45 square, 0.45 square into 0.55, 5 as well as 5. For the third case, if we choose 3 out of 3, there is only one way. 3 choose 3 is actually 1. And the value of 0.55 raised to 0 is also 1. So it's just 0.45 raised to 3. Now if we use our calculator, our final result is going to be 3 into 0.45 into 0.55 square plus 3 into 0.45 square into 0.55 plus 0.45 raised to 3. The calculator shows as 0.834. This is what the answer. Well, then the immediate next question says 10 students are selected at random from the students who study science. Okay, as the number of student is fixed, so it is again a binomial distribution. For binomial distribution, we always use the the parameters are n, p, n is 10. And who study science, find the probability that more than 7 students art or music. So art or music, art was, how many were there for art? 0.2. So p is equal to, for art there were 0.2, point 2, I mean 20%, and for music there were 35%, so 0.35. So total probability who study art or music is what? 0.35 20, so 0.55. So the probability those who don't study art or music is 0.45. That means 1 minus p. Well, 10 students and our probability is 0.55. So they have told us to find among these more than 7 students. So more than 7 means there may be 8 students, or there might be 9 students, or there might be 10 students. 10 students. Well, then when 8 out of 10 students took art or music, we will write from 10 we choose 8. So 8 students have taken art or music, their probability is 0.55 raised to 8, and rest 2 students didn't take this, whose probability is 0.45, 2 students. Then out of 10, 9 students have taken, so 10 choose 9, so 9 students took art or music, whose probability is raised to 9, and only 1 student didn't take art or music, whose probability is 0.45. Okay, then if all 10 students took all 10 students took art or music, then their probability is 0.55, all 10 students, and there is no one who didn't take art or musics, their probability is 0. Now if we simplify this, it is going to be 10 choose 8, so we can manually calculate 8 into 10 into 9 into 8 factorial over 2 factorial and 8 factorial, and it is going to be 0.55 raised to 8 and 0.45 raised to 2. Then 10 choose 9. If we choose 9 students from 10, only there are 10 ways, and 0.55 9 times 9 times, only one students didn't take art or music, for which it is 0.4 as well as 5. So if we choose all 10 students who took art or music, the probability is going to be 10 choose 10 means actually 1, and this is 1, so it's finally 0.55 all 10 students. All 10 students means 10 times. Well, then if we simplify more, it is going to be 8 can dissolve each other, it is going to be 2 factorial means 2, so it is 5. Okay. So 5 nines are 45. If we use our calculator, 45 into 0.55 raised to 8 into 0.45 square plus 10 into 0.55 raised to 9 into 0.45 plus 0.55 raised to 10, our final answer is going to be, it is 5, sorry, it is 5. Then our final answer is going to be 0.0996. 0.0996. That is the answer to whole of this question. Let me show you all the solutions together. Well, next we are moving on to the next question. Next question is on the next page. Question number 3 says a fair six-sided dice with faces labeled 1, 2, 3, 4, 5, 6 is thrown repeatedly until a 3 is obtained. The number of throws taken is denoted by the random variable x. Find probability of x is equal to 8. That means find the probability if 8 throws were made to obtain a3. So here the clue word is until. Until is the clue word. Until indicates that it's a geometric distribution. So we will write x belongs to geometric distribution, because whenever 3 is obtained, then experiment is over. So for geometric distribution, our probability, there is only 1 out of 6 3. There is only 1 3. So it is 1 over 6. Means our P is 1 over 6 probability, and failure Q is equal to 5 over 6. Well, that means obtaining a 3 is 1 over 6. Obtaining probability of not obtaining a 3 is 5 over 6. So they have told x is equal to 8. So when probability of x is equal to 8 equal to, that means in out of 8 throws, once there was a success, and in rest of the 7 cases it was failure. So failure is 7 times. Okay, 7 times. So finally our answer is going to be 0.0465. 0.04 0 sorry 0.0465. Then find probability when x is less than 9. That means in any of the times among this 9, the 3 has been obtained. So probability of x less than 9 is equal to somewhere among this, that is 8 equal, not less than 9 means it is either any of the 8 throws he succeeded to obtain a3. So it may be 8 throws or less than that. So the formula of probability of probability of x less than or equal to 8 is 1 minus q raised to our q is this. Q is 5 over 6. So 5 over 6 is the failure out of 8 times. In all 8 times we didn't fail, somewhere we succeed. So it is equal to, if we use our calculator, it shows 0.767. 0.767. I think you got my point, that the formula for less than or equal to is 1 minus q raised to r. Q raised to 8. I mean q raised to r. R means the number of trials among which success is attained. Let's see question number C, the final question of this paper, of this question. Final part of this question says, find the probability that 3 is obtained for the second time before the sixth throw. So let us see probability of second 3. Second 3 before sixth throw. Sixth throw equal to. So the concept of the question is actually he might get succeeded to obtain 2 threes when he threw the dice for the 2 times. So it may be x equal to 2. He might get succeeded in first 2 throws, or he might succeed 2 threes throwing 3 times, or he might get succeeded after throwing 4 times, or after throwing for the 5 times, because less than 6 times. So less than 6 times means he might get succeeded to obtain through 2 threes in the first 2 throws, or in the first three throws, or in the first four throws, or in the first five throws. If in the first two throws he obtained 3, so both of them are success. That means 1 over 6 into 1 over 6. That means both of the first two cases he got succeeded. Okay, now if he had to throw 3 times, so there were, one thing is very sure, in the third throw he got nothing but success. In the this is for the third throw, and among the first two throws he succeeded once and he also failed once, but we don't know when he succeeded or failed. That's why we will choose one. Once he succeeded, but another time he failed. That is 5 over 6. 5 over 6. I think you got my point. That, look at this, there are 3 throws. Among the 3 throws, why will he throw 3 times? Until he obtains a second 3. That means he obtained first 3 in any of the first 2 throws. On the third throw, definitely it was success, because he threw 3 times for 2 threes. Okay, so first one is third throw is definitely confirmed that it is success. Among the first 2 throws there is a confusion. That's why we have applied the binomial concept. Well, for the third case, suppose he threw for 4 times, and fourth time he must obtain a 3 probability. Now among the first 3 throws, so there are 3 throws. Among these 3 throws he succeeded only once, but we don't know when he got succeeded. That's why we are applying combination formula. Once succeeded, 2 times failure. 2 times failure. For the fourth case, suppose he might, so for the third case, when he threw for 4 times, so on the fourth time he obtained a 3 whose probability is 1.6. But among the first 3 throws, he, sorry, it is not 4, x is equal to, sorry, this is for x equal to 5. That means he threw for the 5 times. So on the fifth trial he succeeded, but among first 4 trial we don't know when he obtained a 3. So among the 4 successes once and 3 times he failed. So 5 over 6. I think you got my point. So every time, the final time he must got succeeded, because whenever he succeed, then experiment is over. That's why at the last stage in geometric distribution, in the last stage there is nothing but success. But among the first few throws or few cases, there may be one success, but we don't know what that exact time of throw is. That's why we apply the combination formula. So if we calculate this, it is going to be 1 over 6 into 1 over 6, sorry, 1 over 6 square. First one is square and this one is plus. 1 over 6 square plus, here 2 choose 1 is also 2. So 2 into 1 over 6 into 1 over 6 and again 1 over 6 into 5 over 6 plus 3 choose 1, it means 3. If we choose 1 from 3, there are 3 ways, 3 different ways. So 3 into 1 over 6 into 1 over 6, and failure is 2 times, 5 over 6 square plus 4 choose 1 is 4 into 1 over 6, again 1 over 6 because there were 2 successes and 3 failures, 5 raised to 6 whole cube. Then if we use our calculator, it will show that our probability of obtaining second 3 before sixth throw is equal to 0.196. 0.19 and 6. Let's see the next question, and I think you have understood as I have explained. This is all about question number 3. Let's move on to question number 4. Question number 4 is over here. It says 84 people attempt a particular puzzle. The times taken in minutes to complete the puzzle are recorded. These times are represented in the cumulative frequency graph below. And the question number 8 says use the graph to estimate how many people took between 4 and 7.5 minutes to complete the puzzle. Well, let's see the graph. So the question told use the graph to estimate how many people took between 4 and 7.5 minutes to complete the puzzle. So according to the graph, 4 second 4 minutes were taken by 37 students and 7.5 minutes were taken by 70 students. So if we find the range between them, 70 minus 37 equal to 43 students. So 43 students took time between 4 and 7.5 minutes. Okay, that is the answer. Let's see the next question. Question number, yes, this question is on the grid below, draw a box and whisker plot to summarize the information in the cumulative frequency graph. Okay, so for box and whisker plot, actually we require 5 information. Okay, the informations are, let us write 5 informations are, first of all, minimum value or least value. Okay, minimum value, then lower quartile, after that there will be median, then upper quartile, third quartile, and finally maximum data. So minimum and maximum are known to us. Let us see from the graph. Here minimum is 2 minutes. Okay, minimum is 2, so we can apply 2, and maximum can also be copied. Maximum was maximum 12 minutes. So minimum 2 minutes, 2 minutes, and maximum 12 minutes. Okay, now lower quartile. Let us see total how many students are there. It is given here that total number of student is 84 people. Okay, so 84, Q1 is going to be 84 over 4 means 21 student. Then third quartile is going to be 326 or 63 63rd students. Okay, 63 students. Now let us see how many times were taken by 63 students. Okay, if we look at the diagram, we will see that lower quartile, that means 21st position, falls in 3.8. This is 3.8, and upper quartile is actually 6.5. 6.5. 6.5. So these are the lower quartile and upper quartile. For lower quartile you will divide by 4 the total data, total number of people, and for upper quartile you will multiply by 3 over 4. So our quartile 1 is 3.8 minutes and upper quartile is 6.5 units. Let it be written. And our median, okay, median is going to be, let me show median again. Our median time is going to be 4 point, here we can write median time is going to be 4.8. So let this information be substituted. Lower quartile was 3.8. It is 3.8, and our median was 4.8, 4.8, and upper quartile was 6.5, 6.5. Okay, now we are going to draw the box and whisker plot. Let me draw this. I'm going to switch the video on because it may take a lengthy time. So this is our box and whisker plot starting from 2 and maximum value is 12. So let's see what the next question says. Question number 5. It says bag A contains 6 red marbles, 5 blue marbles and 1 green marble. Bag B contains 5 red marbles and 3 blue marbles. A marble is chosen at random from bag and placed in bag B. A marble is now chosen at random from bag B. Draw a tree diagram to represent this information, giving the probability on each branch. Well, we are going to draw a probability tree. Tree diagram. So there are two bags. Suppose bag A. This one is for bag A. Okay. Bag A. Bag A has three different marbles. First one is red. Second category is blue. And third category is green. So there are total 12 marbles. Out of 12, 6 are reds. So the probability is 6 over 12. And there were 5 blue marbles. So probability is 5 over 12. And there is only one green marble, so probability is 1 over 12. Now these marbles, that means this marble has been kept into the second bag. So the has second bag has two different kinds of marbles. Number one is red or blue. Then here also red or blue, red or blue. And then for the third case, look at this. For the third one, it will be red, blue or green, because second bag doesn't have any marble whose color is green, sorry. That's why newly in the second bag will have three different branches. So red, blue or green. Now let's see. It is written that the bag was, first let us write here, this is bag 1, and this is for bag 2, bag 2. Okay, look at this. The scenario says when a marble is chosen at random from bag A and placed in bag B. So in the bag B, always one more marble will be increased. In the bag B, how many marbles are there? Total 5 plus 3. So total there will be 9 marbles. Though there were 8 marbles, but one marble has been placed from bag A. So total number of marbles in bag B is going to be 9. Now let us complete our diagram. Yes. So first one was red and it was kept in the second bag. Second bag has 5 red. Now there it has become 6 reds. Out of total 9. 5 plus 3 plus 1, 9. So it is now 6 over 9. Okay, if first one was red, second one was blue, so blue marble, number of blue marble will not increase. It is going to be 5 over 9. 5 over 9. Then there comes how many blue? Sorry, 3 marble, 3 blue marbles, not 5. It was 3. Second bag has 3 blue marbles, so it is going to be 3 over 9. Okay, now for the second branch, it is first one was blue and second one was red. So if red marble were 5, so it is 5 over 9. Let me change the ink. 5 over 9, no, 5 over 9. It is now 5 over 9. 5 over 9. And if the first one was blue, second one was also blue, there were 3 blue marbles. Now it is getting 4, and total is also increased to 9. Now if first one was green, second one red, so red there were 6 marbles, and still 6 marbles, but total number of, there were, sorry, 5, not 6, there were 5 red marbles in the second bag, so it is going to be 5 over 9. 5 over 9. Then what about blue? First one was green, so blue will not increase. So blue is going, there were 3 blue, still there are 3 blue, and total number is going to be 9. Sorry, this is red. Red is, so long it has been easy, but the twist is now to be handled. Look at this. In the first bag there was green, but in the second bag doesn't contain any green marble at all. So what will happen? One marble has been given, so there is only one green, and total marble has been increased to 9, so it is 1 over 9. So that's all about the tree diagram. I think you have understood the explanation I have made. Let's see the next question. The next question says find the probability that both marbles chosen are same color. So probability of same color. Same color. So for what are the possible cases for same color? It may be both of them blue or both of them red. Okay, for being blue, for the from the first bag it was, sorry, there is one more case. Both of them can be also green. Both of them can also be green, because there are 3 different kinds of color of the marbles. So if the first one is blue, the probability is going to be 5 over 12, because there were 5 over 12. And if the second one is also blue, so it is going to be 4 over 9. Plus if the first one was red, then the probability was 6 over 12, 6 over 12, and it is kept in the second bag, so it has become 6 over 9, 6 over 9. If the first one was green, the probability was 1 over 12, 1 out of 12 marbles. If it is kept in the second bag, there was only 1 green marbles out of 9. Hence our probability is going to be 0.529. 0.529 is the answer. Let's see what the next question says. The next question says find the probability that the marble chosen from bag A is blue, given that the marble chosen from bag B is blue. First of all, we will have to find that both of them are blue. Okay, this is blue and second one is also blue. So we will find probability of blue from first bag, blue from bag 1 intersection blue from bag 2, blue from bag 2, bag 2. Okay, so it is going to be, for the first one, if we pick up a blue marble, the probability was 5 out of 12, and for the second one it was 4 over 9. That means from both ones we are picking up blue. So this is blue, blue. Okay. Finally, it is going to be 20 over 108. Then we will find the second one is blue. Okay. The bag, second blue from bag, second blue from bag 2. Bag 2. Okay. Second one blue from bag 2. So what are the possible cases? It is that second one should be blue. About first one there is no restriction. So first one may be red and blue. First one may be blue, second one is also blue, or first one is red and second one is blue. So if the first one is red and second one is blue, our probability is going to be 6 over 12 into 3 over 9, 3 over 9, plus if our both of them are blue, we have just written it is 5 over 12 and 4 over 9, 5 over 12 into 4 over 9, plus if first one is red and second one is blue, there are only, sorry, not red, it will be green. If first one is green, it was 1 over 12, and for being second one as the blue is 3 over 9, 3 over 9. So finally it is going to be 108, and if we add up 18, 20, 38, 38 plus 3, 41. Now we will write what the question told. The question has told us to find, yes, on the right side we can write with different ink. So it is written probability of first blue from bag 1, from bag 1, given that probability of, oh sorry, given that blue from second bag, from second bag, from bag 2, bag 2. So equal to, we know that if it is written given that, how to write, the notation, it is probability of both of them, blue and blue, from bag 1 and bag 2, and the second one is, sorry, it is not in this way. Let us write blue intersection blue, from both bag it is going to be blue, and then for the second one only blue. For second one blue, it is first one may be red, first one may be blue, and first one may be green. Second one is blue. So the probability we have obtained is, for both of them blue, what was our probability? If both of them were blue, our probability was this. And if only second one is blue, so the possibility is 41 over 108. So we can divide it by 20 over 108 over 41 divided by, I think I can write just below this, over 41 over 108. Now if we divide 20 by 41, it is going to be 0.528, 0.52 as well as 8. That is what the final answer is. Let me show whole of the solutions at a glance. Let's see what the immediate next question say. The next question says, a company sells bags of pasta. The masses of large bags of pasta are normally distributed with mean 2.5 kg and standard deviation 0.12 kg. find the probability that mass of pasta in a randomly chosen large bag is less than 2.65 kg. So already they have mentioned that it is a normal distribution. So let us write the normal distribution. The parameters for normal distributions are x belongs to normal distributions, and parameters of normal distributions are mean as well as variance. So mean is 2.5 and variance is square of the standard deviation. Okay, now they have told us to find the probability of mass bag is less than 2.6 kg. So x is less than 2.65, or if we standardize the score, z is less than 2.65 minus 2.50 over the standard deviation, which is 0.12. So if we simplify this, it is our z score is going to be 2.65 minus 2.5 over 0.12. It is 1.25. 1.25. Okay, then as our z score is positive, so there is no necessity of adjustment. We will find for probability when z score is 1.25, we will find the probability. Z score is 1.25. 1.25. So 1.1 is here, 1.2 is over here, and 5 falls over here. So this is the column. So finally our corresponding probability is 0.8944. So 894. Simply this is 894 equal to 0.894 is our probability. Then the next question says, a restaurant manager buys 160 of these large bags of pasta. Find the number of bags for which you would expect the mass of pasta to be more than 1.65 standard deviation above the mean. Yes, there is a twist, and there are two twists. One is this expected value. For expected value means that is mean into probability. So first mean is already given, not mean means probability into total number n. Total number is given, we are going to find the probability. Okay, so for probability, what is it given? Let us see where we are still under the same normal distribution. So probability of x is greater than, is more than. Okay, x is more than 1.65. okay, 1.65 of 1.65 of standard deviation. Look at it, it is written of standard deviation. Standard deviation was 0.12. So as this is more than, so we'll have to add up the mean. Mean is what? Mean was 2.5. 2.5. So this is the twist, remember. This is what the question actually say. Well, x is greater than, more than 1.65 standard deviation above the mean. Above the mean, so you'll have to add up these two mean. Then if we standardize the score, let us standardize the score. Probability of z is greater than, after calculation it is going to be 2.698. So I think first of all we'll have to write x. So x is greater than 2.698. 6, 9 as well as 8. Let us standardize now. If we standardize z score, it is going to be greater than 2.698 minus our mean value is 2.5, 2.50. Standard deviation was 0.12. Now it is going to be probability of z is greater than, if we use our calculator, it is 1.65, 1.65. Okay, so if we draw the figure for this, it is going to be, let me show you from the figure. Okay, they have told us to find this, it is 0 over here and it is 1 point, suppose 1. Okay, the greater parts. Okay, this portion is our probability. Okay, this is the probability we should find. So for this probability, what will we do? We, from whole of the probability, we will subtract the left part. Okay, if we subtract the left part, it is going to be 1.65. Let us write zero point 0.6, suppose. So this is our, the black part is our probability. Okay, so for black part, from whole part we will subtract the left part. How to write? Or probability, sorry, 1 from whole probability, if we subtract the left part, probability of z less than 1.65. Okay, if we subtract the left part, then we will find our required probability. So let's find the probability when the z score is 1.65. Okay, 1 minus probability of corresponding z score is 1.65. So 1.65 is, here is 1.6, this is 1.6 row, and 5 is over here, so it is going to be just over here. So our probability is, corresponding probability is 0.9505. Okay, so let us substitute this, 0.9505, 0.9505. If we subtract this, it is going to be 0.0495, 0.0495, and this is the probability. But they didn't tell us to find probability, they have told us to find the expected value. Look at this, expected value. So for expected value, we write ex. Ex is equal to, we know expected value is equal to the mean value, probability into total number of experiment. Total number of experiment is, probability is point zero four, point 0495, which should be multiplied by 160. Okay, so if you multiply by 160, then our expected value is going to be 7.9 something. So we can write it actually 8, 7.92, 7.92. So if we round it up to, because this is the number of bags. Okay, number of bags cannot be fractional, so we can write 8 bags. So that is the final answer to the question number 6. Let's see question number 7. Next question is on page number 10. Still there is one part of question number 6, which says the masses of small bags of pasta sold by the company are normally distributed with mean mu and standard deviation sigma kg. Tests show that 77% of these bags have masses greater than 1.26 kg and 44% have masses less than 1.35 kg. So find in either order the value of mu and the value of sigma. So probability is also given. we are still under the same normal distribution, not same normal distribution. Our normal distribution parameter is, let us write here, x belongs to normal distribution and the parameters are mean as well as sigma. Okay, sigma square, standard deviation square. Sorry. The first case says the probability when x was more than how much? More than 1.26 kg. 1.26 kg for which the probability is 77%, means 0.77. Okay, 0.77% for 1.6 kg. So if we standardize the score, it is going to be probability of z is greater than 1.26 minus mu over standard deviation, which is sigma equal to 0.77. Well, now if we draw a graph, look at this. From the graph we can see that, yes, suppose this is the graph, and in this graph our z score is, look at this, our probability is 0.77. Which part? Right side of z score. So for being 0.77, it is actually this part. This part is our probability. Okay, this dark part. So what does it means? Actually our z score is z score. Our z score is negative because it is lying left side of 0 mean line. So this is definitely negative 1.26 minus mu over sigma, and as it is lying on the left side of the mean line, this is the mean line when standard deviation is 0, so definitely this is negative. That's why we will have to write probability our z score is negative something. Now the probability is 0.77. For probability as 0.77, we will find what is the corresponding z score, and already we have decided the location of z score, which is on the left side, that's why negative. So 0.77 is our probability. From probability distribution table we will find 0.77 as our probability. Let us see 0.77. 0.77 here, if we look, this is 0.6985 and 15 more is required. So for 15 maximum we get, the closest one is 14. We can get 14. It is actually closest to 0.77. So our z score is this 0.5. First row is zero point 0.5 and column is zero point 0.2. Sorry, it's a great mistake. We are supposed to find 77, not 70. Sorry, it's a great mistake. So for 700, more than 7, 7 we will have to get 7 6. Yes, this one can be chosen. This one, for this one 7 6 73, but for being 7 7 0 0, it is going to be actually 73, and we can pick up from this column, it is the final one. If we add up these 27 to 73, then it is actually 0.77. So our row is zero point 0.7 and first column is zero point 0.3 and third column is 0.9. It is 9. Okay, so it is point, it is 0.739. So let us write 0.739. Our z score is 0.739, 0.73 as well as 9. Okay, and if we compare the z score, it is going to be 1.26 minus mu over standard deviation is equal to negative 0.739. Already we have decided why should it be negative, because it is lying on the left side. Or sigma is equal to, if we dissolve the negative symbols, it is going to be mu minus 1.26 over 0.739. Okay, we will have to form two simultaneous equations because two of the values should be obtained. Okay, this is the first case. For the second case, we will see that probability of, what does it say, less than or equal to, it says x is, the second one is 44% have masses less than 1.35, 1.35. So x is less than 1.35, x is less than, and before that we should write something. Probability of x less than 1.35 kg, 1.35 kg, and the probability of bag is 0.44, 0.4 as well as 4. If we standardize the score, it is going to be z less than 1.35 minus mu over, our standard deviation is sigma equal to 0.44, or probability of z less than equal to 0.44. So let us draw another diagram. From here, this is the normal diagram, so from which our probability is, in this case probability is 0.44, so definitely it is small. But where is it lying? It is lying on the left side. Look at this part is 0.44, 0.44. So this is the probability we should know, 0.44. So what we should do, this probability, and here our z score is 1.35, 1.35 minus mu sigma over sigma. So surely it is lying on the left side, that's why it is negative. And for this less than negative, now what do we need? We will have to get the z score for this small part, but always all the probabilities are more than 0.5, that is half, more than half. So we will find, if this portion is 0.44, this portion is going to be 0.56. So we will find rather the greater part. Okay, the probability of the red part is 0.56. So let us find 0.56, because none of the probability is less than zero point 0.5 in the probability distribution table. So let us see when probability is 0.56, what is the corresponding z score? 0.56. So from here we'll have to find 0.56. Let us see. Let me erase the previous one. 0.56. So 0.5596. Look at this. Here it is 0.5596. 4 more is required, and this one is 4. So what is our column is zero point 0.1, and sorry, row is column zero point 0.1, and first column is 5 and second column is 1. So it is actually 0.151. Let us substitute this. It is 0.151 is our z score. 0.151. Now if we compare the z scores, hence, or 135 minus mu over sigma is equal to negative 0.151. If we make sigma as subject, then it is going to be by dissolving the negative symbol, it is going to be mu minus 1.35 over 0.151, and it may be left as equation number 2. Okay, this is equation number 2. So we are going to solve both the equations simultaneously. Let us write from equation from equation 2 and 1, and this is, sorry, this was equation 1 and this should be 2. Okay, from equation 1, mu minus 1.26 will be divided by 0.739, and for the second equation also right side is left side is sigma, so right side is equal mu minus 1.35 over 0.151. So this is our equation. Now we are going to solve these equations. So it is going to be 0.151 mu minus, if we multiply 1.26 and 0.151, it is going to be minus 0.99765. 0.99765 is equal to 0.739 mu minus, if we multiply 1.35 with 0.739, it is going to be 0.19026, 0.1902, as well as 6, 2 and 6. So if we subtract this mu, it is going to be negative. No, it's a mistake. We made a disorder. So let me erase this. Yes, that should be the step. Now if you subtract 0.151 from 0.739, it's going to be 0.588. 0.588 mu is equal to, if we subtract 0.19026 from 0.99765, it is going to 0.80. 0.80739. Thus our mu is going to be, if we divide this quantity by the left side, it's going to be 1.37, 1.37, 31122, if we round it up to 3 significant figures, then it is going to be 1.37. This is our mean value. Now we are going to find our standard deviation. Okay, for standard deviation we can pick up any of the formula, any of the equation. So let us pick up the first equation. So hence our standard deviation is equal to, mu is what, 1.3731122 minus 1.26, which will be divided by 0.739. Hence our sigma is going to be 0.153. 0.153 is the value of our standard deviation. So these are the two answers to this final question, or final part of this question number 6. This is all about 6C. Now we are moving on to question number 7, the final one. Let's see what the last of all question says. It's number 11. Okay, it says that a set of friends consists of 7 men and 4 women. 3 of men are brothers, Ali, Ben, and Charlie. Find the number of different arrangements of the 7 men in a line in which Ali and Ben do not stand next to each other. So, what is the scenario? The scenario is number of arrangements. What do? We find the we apply the concept of the permutation. So before that, let us write the scenario. The scenario is Ali and Ben is the condition. Okay, restriction is Ali and Ben. So except Ali and Ben, there are total 11. There are 9 different Ali and sorry, only the men. It's about men. So there are 7 out of 7. If 2 goes away, there are 5 men. So 1, 2, 3, 4, 5. So these 5 people may interchange their position with 5 factorial ways. Then the rest two, Ali and Ben. Okay, these two, this Ali and Ben may be over here. Ali may be over here. Ben may be over here. Their position may be this in between other men. Okay, so how many places are left for Ali and Ben? 1, 2, 3, 4, 5, 6. So let us write number of arrangements. For arrangements, always we apply the concept of permutation equal to, first there are 5 men for 5 different men, there is 5 factorial ways. And about Ben and Ali, they have total 6 positions. Out of 6 places they will occupy 2, and they will have to be arranged. That's why it is permutation, means 5 factorial into 6 factorial over 6 minus 2 is 4 factorial. So finally number of arrangements is going to be 3600. 3600 is the number of arrangements. Let's see the immediate next question. The next question says, find the number of different arrangements of the 7 men and 4 women in a line in which all the men stand together and all the women stand together. So very simple. Suppose this is for men and that is for women, and here there is partition. Partition means that this is the side has been defined. So 7 men on one side and 4 women on the other side. Okay, so we will write number of arrangements arrangements is equal to, for 7 different men they can interchange their position in 7 factorial ways, and 4 women can also interchange their position through 4 factorial ways. Now the question is, these women may go to the left direction, whereas men can also go to the right direction. So there are 2 more possible cases for their arrangement. So finally it is going to be, if we multiply this 7 factorial into 4 factorial into 2, it is going to be 240 100 920. There is 24 lakh sorry 2,41,920 ways they can be arranged. That is the answer. Question number C is on the next page. Yes. Question number C says, in how many ways can 7 men and 4 women can be divided into a group of 6, a group of 3, and a group of 2 if there are no restrictions? So without restriction, simply we can find this. There are 3 groups. So for the first group, it is 6, 3 as well as 2. So out of 11, number of selections can be written. Number of selections, and for number of selections we apply the concept of combination. Number of selections is equal to, first there are 8, out of 8 people we are choosing 6 for the first group, and for the second group there remains 5, out of 5 we are choosing 3 people, and for the third group there remains 2, so we are choosing both of them. So if we write this, it is 11 factorial into 5 factorial into 2 factorial. 2 is not necessary because 2 is actually 1, so we can skip that. And the denominator is going to be 6 factorial into 5 factorial into uh, 2 factorial into 3 factorial. Okay, you can use this multiplication symbol while using calculator. Please don't forget to use multiplication symbol. So finally our number of selection is going to be 4620. 4620 ways is the answer. Let's see what the last of all questions say. It says the 7 men and 4 women are divided at random into a group of 6, a group of 3, and a group of 12. Like the previous question, find the probability that Ali, Ben, and Charlie are all in the same group. So there are what are the possibilities? Group of first group of 6. Okay, for the first group, then in the second group is for group of how many? 3 people. Here 3 people. Group of 6. Okay, of 6 and of 3. We can write actually people. Okay, so first there are 6 people in the first group. In the second group there will be 3 people, and in last of all there will be 2 people in the third group. So they told that Ali, Ben, and Charlie must be in the same group. So A, B, C, Ali, Ben, and Charlie is already there. So in the first group, for having 6 people, we require 3 more people. Okay, then these 3 people can be chosen from the rest of them, and from the remaining ones we will choose 2 people. So this is one of the case. What is this? And the second case, suppose in the first group Ali, Ben, and Charlie are not in the first group, so there are 6 people to be chosen, and Ali, Ben, and Charlie are in the second group. Then third group, there cannot be third group here actually, because as there are 3 people, here there are 2, sorry, there cannot be third possibility because there are only 2 people in the third group, but Ali, Ben, and Charlie are 3 brothers. Okay, so we can write here number of selections with restrictions restrictions with with restrictions. Okay, so with restrictions, first of all we are going to find how many. Among 11 we will choose these 3. Okay, first to 11, choose from 11. This is the first case, we are choosing 3 people for the first team out of 11. Sorry, not 11, already 3 has been chosen, means Ali, Ben, and Charlie. So there remains only 8. As 3 has already been chosen, so there remains 8. Out of 8 we are choosing 3. Then from the second group, there remains, if 3 goes away, there remains 5 people. So out of 5 we are choosing 3 people for the second team, and there remains only 2 people. Out of 2 we are going to choose 2. This is the first case. Now what is the second case? Second possibility is, for the first group we are choosing all 6. So from total people, not total, there already 3 has been chosen for second team. So there remains only 8. Out of 8, we are choosing all 6. And in the second group, there are remaining 5. From 5, we are going to choose. No, we cannot choose actually anything here because all 3 people have already been chosen. So there is no necessity of choosing for second team. It's all about third team. Okay. So for third team there remains, or if you wish you can write that Ali, Ben, and Charlie, they have been chosen 3 out of 3. Then there remains only 2 for which we will choose 2 people. So let us see what is this. In the first case, the it is 8 factorial over 8 factorial into 5 factorial into 2 factor. 2 choose 2 is actually 1, so let us omit this. This is not necessary to be written. So the denominator is 3 factorial into 5 factorial, first denominator. Second denominator is 3 factorial into 2 factorial. Okay, equal to. Then for the second case, 8 factorial, numerator is 8 factorial and 3 factorial. And denominator is 6 factorial into 2 factorial, 6 factorial into 2 factorial, and rest of the cases it is actually 1. 3 out of 3 if we choose, it is 1. So let us see how much is this. Here if we use our calculator, the first number of selections is going to be 8 factorial into 5 factorial over 3 factorial into 5 factorial into 3 factorial into 2 factorial. So it is 560 ways. 560 ways it can be chosen. And here 8 factorial into 2 factorial, and that is 3 choose 3 is 1. So we should not apply this 3. Let us erase this. This is not necessary because we are not counting this. If you count, you will have to count the denominator as well. So we are just counting this 8 factorial. Okay, so 8 factorial over 6 factorial into 2 factorial equal to 28. So total number of choices 88, 588. Okay, then they didn't tell us to find number of selections. Actually the question has told us to find the probability. Look at this. So probability is equal to probability. So without restriction, total number of selection was in the first question, I mean in the previous question it was 4620, 4620, and with restriction it is 588. So we will just divide this 588 over 4620, 4620. Then finally our probability is going to be 0.1272. So 0.127, 0.127. That's all about the solution to the last of all questions. Thank you all for being with me, and may Allah bless all of us with the beneficial knowledge. And if you think that these videos are helpful for you, then please subscribe the channel and watch the videos. Thank you.